Our next task is to complete the following tables in order to see exactly what data we need to be keeping track of when we're looking at the contexts and the next possible words. So the table starts with all of the one-word contexts, and it's our job to determine the next possible words. After so, comma, the next possible word is as. After as, there are two possible words, fast and I. After fast, we have only one option, which is as, and so on. After the word net, there are no next possible words. We'll talk about that more later. Now we're going to do the same thing, only this time, instead of just one word of context, we will use two. So after the two words so, comma, as, the only possible option for our next word is fast. After as fast, the only option is as. After fast as, it's I, and so on. Again, after my net, there are no possible next words. Now that we've gone through the exercise of filling in these tables, we need to decide which type we should be using in order to represent this data. We can see that the contexts are one or more words, and words we can represent using strings. Since we need to possibly represent more than one, we need some sort of collection, like a list, a tuple, or a dictionary. The order matters, so that means that a list or a tuple would be preferable. We also need, though, to keep track of the context relative to the words that come after it. We want a connection between these two. So the type that I'm proposing to use is a dictionary, where each key is the context and each value is the words that could follow that context. Both of these need to be sequences, but the keys of dictionaries must be immutable. So that would make the type that we're looking for a dictionary where the keys are tuples of strings and the values are lists of strings.